These are the most basics of basics, and you have to know these things for you to understand algebra, especially if you're doing algebra for the first time. Alright, let's get cracking. So it's introduction to algebra. Now what happens is, we are normally used to dealing with numbers, but in algebra we start dealing with letters. In other words, we have to add, subtract, multiply and divide, find square root, etc. of letters. So we have to understand how things work in algebra. So the first thing is, we have to understand the difference between the way numbers are treated and the way letters are treated. For example, consider 245, the number 245. Then 245 is equal to 200 plus 40 plus 5. So that's what we are used to. But in algebra we're going to start dealing with letters. And suppose I gave you A, B, C. Then you have to know the difference between these two. Now in algebra, A, B, C means A times B times C. Now you can see no multiplication signs here at all, but you have to know that's what it means. Number 3, if I gave you A plus B, well, that is what it means. It means A plus B. There's no problem with this. If I gave you A minus B, there's no problem. It means A minus B. I can tell you A divided by B. Well, that's not a problem. But the problem is with A, B, C, which really means A times B times C. So can you see the difference between these two? 245 is 200 plus 40 plus 5, whereas ABC is equal to A times B times C. So that's the first fundamental difference, or first very important difference that you have to know about. So for fun, if I told you what is DOG, then you cannot tell me dog, because we are doing algebra. And DOG in algebra means D times O times G. Or written differently, it's D bracket O bracket G, because brackets mean multiply. Alright, so that's the first basic difference that we need to know. Let's move on to the next thing. Now let's look at multiplication and be clear in our mind about signs for multiplication. You see, there are many signs for multiplication. We are familiar with, for example, A times B. Well, that means A times B. But this can also be written as A dot B. Or it can also be written as A in bracket and B in bracket. Or it can be written as A there and the B in bracket. All these mean A times B. Well, it's still not finished. Or it can be A asterisk B. Now all this is telling you to multiply. The next important thing is division. Let's be clear in our minds about division. So if I wanted to tell you 10 divided by 2, I can rewrite it like that, or I can say 10 slash 2. Therefore, in algebra I can tell you A divided by B, or A slash B. Or this 10 could have been written as 10 on top, 2 in the bottom. Therefore, this one can be written as A on top and B at the bottom. So we must be clear that there are many signs for multiplication, and for division we've got at least 3 different ways to write division. Okay. let's move on. So now the first most important word that you're going to learn in algebra is term, T-E-R-M. Term or terms for plural. Now, you got to remember that terms in algebra are separated by plus and minus signs. By plus or minus signs. For example, 5 is a term. 7 minus 3, here we have two terms. Now in algebra there will be letters, so A is a term. Now in front of A you can see nothing. I am saying it is separated by plus or minus signs. While in front of A it is understood that there is a plus written down. It was not there, but it is understood. So understood means it is there, but it is not written. So if you take A plus B, then those are two terms, because terms are separated by plus or minus signs. If you take something else, M minus N, you got two terms, because there's a plus that's understood here. So plus M is one term, minus N is another term. Plus A is one term, plus B is another term. If we take a few more examples, if you take a thing like this, 5x squared, then this whole thing is considered a term because the plus sign is understood here. Now, if you move on, if you take an example like this, 5x squared plus 3x, then we say there's two terms here because there's one plus sign understood here. So from this plus sign till here is one term. Then from this plus sign till there is another term. So in other words, in this one you got one term. In this one you got two terms. And in this one we got three terms. There's a plus here, so there's three terms here. Plus 5x squared is one term, plus 7x is another term, minus 3 is another term. So terms are separated by plus or minus signs. Now you have to remember that if things are written inside a bracket, like 5a plus b is written inside a bracket, and I ask you how many terms in this example, then let's make it like this, plus 7. Then this whole thing is considered one term, and plus 7 is considered another term. So in other words, in this example here there are two terms, because there's a plus sign understood here. So from here till here is one term, and then from there till there is another term. So remember that everything inside a bracket, this whole thing is considered one term. So now let's be very clear about English. But if I ask you how many terms inside this bracket, how many terms inside this bracket, then you're going to tell me, well, there are two terms inside this bracket because you are looking here and there. But if I ask you how many terms from here till there, then you're going to tell me one term, because then everything is considered as a term. So watch the English. If we ask you how many terms here, we never said inside the bracket, we just said how many terms. So from here till there will be one term, and from there till there will be another term. But if you look at this one and I ask you how many terms in the bracket, If I'm telling you in the bracket, that means you must look inside here. There's one term inside here and another term there. Alright. So that's your first basic. That terms are separated by plus or minus signs, and all whatever is written inside a bracket is considered as one term. Alright, so we've stopped there and let's do a little exercise. Alright, so let's have a look at this little exercise. How many terms in the following examples? Now, if we're looking for terms, then we are on the lookout for plus or minus signs. So when we look at number 1, there's a plus sign that is understood here. So in maths, we don't always write all the plus signs. So there's a plus understood here. So plus 2a and plus b, the answer here is 2. So if we put a column for the answers, so number 1 got 2 terms. If you take number 2, there's a plus that's understood here. So that's 1 term, and then minus n is another term. So they're separated by plus and minus, so the answer is 2. If we look at number 3, then there is a plus that's understood here. I don't have to write it. So understood means in maths that it is there and it's not written. But anyway, I'm just going to write it now to make it clear. So there's 1 term here. Then there's another term from there right till there. And then there's another term from there right till there. So this one has got 3 terms. Now this one, you've got to be careful. There's a plus sign here. So that's 1 term. So that's 1 term. And then all this here forms 1 term, because we said whatever is inside a bracket is all considered as 1 term. So from here till there is 1 term. So altogether in this example you got only 2 terms. So you got to remember the story about the bracket. Now if you look at this example, there's a plus understood here. So you got plus a squared, that's 1 term. And then from here right till there is only 1 term, because the pluses are separating the terms. So that's 1 term. From here to here is 1 term. And then from here right through till there is another term. Right? Because there's 1 plus sign. Or another way of getting the answer is to count up the plus and minus signs. So there's 1 plus sign here. Then there's the next plus sign. So there's 2 terms. See, this whole thing is considered a term. If you take this one, there's a plus sign here, and there's a minus sign here. So this is 1 term, and minus 4 is another term. So the number of terms here is 2. And if you take the last one, number 7, there's a plus sign here, understood, so that's 1 term. And then minus 4 into the bracket, this whole thing here, right till here, is considered 1 term. So this whole thing is 2 terms. 1 term here, and that whole thing there is another term. So this is how you identify the number of terms. Alright, so what we're going to do now is we're going to give you a little exercise, and you must be able to identify the number of terms in that exercise. Alright, so here's a little exercise for you to do. Number 1, plus 2a minus 5. Number 2, minus 5m plus n. Number 3, plus m squared plus 2ab plus b squared plus d. Number 4, a squared plus open bracket a minus m close bracket plus a. Number 5, m squared plus open bracket a plus m close bracket, minus 3n. Number 6, x squared minus 4. Number 7, x squared minus 4, open bracket, a plus b, close bracket. In these examples, you must write down how many terms. So, you can take the questions down and fill in the answers. Now at this stage, take these things down, switch off the DVD, fill in your answers, and once you have completed, we will then supply you with the right answers. Alright, hard-working learners, good. I hope you had switched off the DVD. Let's see. So number 1, plus 2a is one term, minus 5 is another term, number of terms 2. Number 2, minus 5m is one term, plus n is another term, number of terms is 2. So like we told you earlier on, terms are separated by plus and minus signs. So even if you just counted the plus and minus signs, you'll get the answer right. That's 2, 1, 2. So if you try this one, it will be 1, 2, 3, 4. The answer is 4. But it's nice to understand it thoroughly that look, plus m squared is one term, plus 2ab is another term, plus b squared is another term, plus d is another term, so there's 4 terms. Now when it comes to number 4, you've got to be sharp and you've got to remember that whatever is in the bracket is considered one term. So that's one term, that's 2, that's 3. But for lazy people, it'll be 1, 2, 3, 3 terms. For those who like understanding, and that's what we should be all trying for, plus a squared is one term, plus all this is one term, plus that is one term, 3 terms altogether. Number 5, again we got a bracket, so we're going to remember that everything inside the bracket is considered one term. So you got one term, well a plus is understood here, one term, 2 terms, 3 terms. Number 6, well a plus is understood here, so that's plus x squared is one term, minus 4 is another term, so the answer is 2 terms. And if you take this last one, well, there's a plus sign here, so that's plus x squared is one term, and then you got minus 4 into a plus b right till here. From here right till there is one term. So altogether here, there's 2 terms. Or you could have just counted like this, 1 plus 1, 2 terms. So you must be able to work out how many terms there are in an expression. So if you take this whole thing, it's called an expression. Each one of these is called an expression, and you must be able to work out how many terms there are in these examples, or another word for the examples will be expressions, in these expressions. So, I hope you did well, and I hope you got 7 out of 7 for this exercise. Alright, so now the next important idea that you must know when learning to do algebra is, what are factors? Well, in simple language, we say that factors are separated by multiplication or division signs. Now let's understand what is a factor. If you take the number 6, 6 is equal to 2 times 3, or 6 is equal to 6 times 1, or 6 is equal to, well, if you have done integers, minus 3 times minus 2. Of course, you are in grade 8 and you have done integers. So, now, these are factors. So here we have two factors because they are separated by a multiplication sign. Here we have again two factors. So factors are separated by multiplication or division signs. Most of the times they are separated by multiplication signs. If you take 18, 18 could be 18 times 1, or 18 is equal to 2 times 3 times 3. 2 times 3 is 6, 6 times 3 is 18. So now you got 1, 2, 3 factors. So we must be clear in our mind that factors are separated by multiplication or division signs. Let's take an example for division. 10 divided by 2 gives us 5. So 10 and 2 are factors. But most of the time we'll be dealing with multiplication signs. So let's understand this, that factors are separated by multiplication or division signs. And therefore we say that 10 divided by 2, it's got two factors here. 18 is equal to 2 times 3 times 3. That gives us 3 factors. So now this is numbers. Now let's take an example in algebra. Let's look at a number of examples in algebra. If I gave you A times B, then here we have 2 factors because they are separated by a multiplication sign. Now remember, in algebra we have a number of signs for multiplication. So 2 asterisk A also means 2 times A. So here there's 2 factors also. Number 3, 5 dot m times n. Well, this stands for multiplication also. So that's one factor, that's another factor, and that's another factor. So there's 3 factors here. So you see, it's not wise to count up signs, but it's wise to understand what a factor means. This is a factor. 5, m and n are the 3 factors. So this is 3 factors. Now let's take another example. 2 into a plus b. Now in this case 2 is one factor and the whole bracket is another factor. 2 is one factor and the whole bracket is another factor. So in this case we got 2 factors. Right. Number 5. 12 divided by 2. So we have a division case here, and therefore there's 2 factors. So factors must be identified, and factors are usually separated by multiplication signs. In this example here, there is no multiplication sign, but it is understood that this means 2 times that bracket. Therefore, there are 2 factors here. 2 is one factor and the whole bracket forms another factor. Alright, so let's do a little exercise on factors. Alright, now here's a little exercise. Here are the questions, and over here we want to write the number of factors. So in our mind we know that factors are separated by multiplication or division signs. Well, here we have a multiplication sign and a multiplication sign. So the number of factors here are 1, 2, 3. So number 1, there's 3 factors. Number 2. Well, I hope you're guessing an answer in your mind. And I hope that you guessed 3. Because asterisk means multiply. So that's 1, 2, 3 factors. Have a good look at number 3. These dots mean multiply. So there's 1, 2, 3. 3 factors. It doesn't mean every time you'll get 3 factors. It just happened that these 3 have 3 factors. Now when you look at this example, 2 important things happen. Firstly, there's no multiplication sign here, but we understand that this is a multiplication example. So it's 5 times the bracket. The multiplication sign is understood. Understood means it is there, but it's not written. So 5 is one factor and a plus b is another factor. So altogether we have 2 factors. When we look at number 5, I hope you worked it out. Yes, if you said 3, you are right. Because 5 is one factor. And then a plus b in the bracket is another factor. And then c in the other bracket is also a factor. So there are 3 different factors here. This number 5 could have been written like this. 5 times a plus b times c. So you can see clearly that there's one factor, there's another factor, there's another factor. So that's why this has 3 factors. Alright, so these are the basics, and so far you should be able to identify terms and factors. So in your mind by now, you should have a little picture. And that picture in your mind should have been the terms I must look for plus or minus. Factors I must look for multiplication or division. That is what you have learned so far, and you must be able to distinguish. Terms are separated by plus or minus. Factors are separated by multiplication or division. Now what I'm going to do now is I'm going to put on an exercise just now in which you will have to identify the number of terms and the number of factors. So if the example got factors, you must tell me how many factors it's got. If it's got terms, you must tell me how many terms. Alright, so get ready for the next exercise. Good. Now let's look at exercise B. You've got to study each question and then write down the number of factors or the number of terms. Each question got only one answer. The answer will be it has so many terms or it has so many factors. So what you're going to do is take the questions down, switch off the DVD, write your answers, and then thereafter switch on again so that we can give you the answers. Alright, switch off now and try these examples. Okay, so if you look at number 1, A, B and C are separated by plus signs. Therefore, these are all terms and there are 3 terms. If you look at number 2, A, B and C are separated by multiplication signs. Therefore 1, 2, 3. 3 are factors because factors are separated by multiplication signs. If you look at number 3, you got 2 plus A plus B plus C. Now remember there's a plus sign in the front here also. So that's 1 term, 2 terms, 3 terms, 4 terms. You see, all separated by plus. So here we have 4 terms. Now number 4, you got to be careful. You cannot see a plus sign or a multiplication sign here. Well, it's understood to be multiplication. So it's 2 times that bracket. Therefore, there are 2 factors over here. Therefore, there are 2 factors over here. If you are a very wise person, You may have also said that, look, there are 3 terms inside the bracket. Yes, it's true, there's 3 terms inside the bracket. But when you look at the whole question, there's only 2 factors, because this whole bracket is considered as one factor. Number 5. 5 is one factor and the bracket is another factor, so the answer is 2 factors. Number 6. These are all separated by plus signs. Therefore, there are 3 terms. You know that a plus sign is understood here. So it's plus 5, plus x, plus 4. So that gives you 1, 2, 3 terms. Right, let's just do one more. Number 7. Minus m plus b. Minus m plus b. Well, in this case, we have 2 terms, because you got minus m, which is one term, and plus b, which is another term. So you have 2 terms. So you must be able to distinguish between terms and factors. Remember, terms are separated by plus or minus signs, and factors are separated by multiplication or division signs. Idea that we must know in algebra is the idea of powers. Now let's explain what is a power. If you take 2 cubed, then what this means, it means firstly 2 times 2 times 2. That's what it means. Now if you go back to 2 cubed, you can label each part. The 3 is called index, or it is called exponent, E-X-P-O-N-E-N-T. The 2 is called the base. And this whole thing is called a power. So 2 cubed is an example of a power. But what happens is, people incorrectly sometimes call 3 a power. But for the moment, if I ask you to label a power like this, that will be your index or your exponent, that's your base, and that's your power. So if I gave you an example like x cubed, then the 3 is exponent, then the x is base, and the whole thing is called a power. So it's very important to be able to identify powers. So if you take 5 squared, firstly we must understand it means 5 times 5. Secondly, we must be able to label it, and therefore the 2 will be labeled good. If you thought of exponent or index, and the 5 is called base, and the whole thing is called good, if you were thinking of the word power. So you must be able to identify powers. So if I tell you label m to the 4, so if I ask you to label m to the 4, then you will tell me 4 is index or exponent, m is the base, and this whole thing is a power. Now this is a very, very important idea, because we are going to be talking a lot about powers when we come back to terms. So you've got to understand powers very, very carefully. So let's take another example of a power. So if you take m squared, m cubed, m to the 4, these are all examples of powers. Now you must understand that even m is a power, because the 1 is not written here, it is understood. So in maths, a lot of things are understood. So the m was written just like that, but the truth is the index 1 is understood. So all these are examples of powers. But obviously these powers are not the same, they are different. This is m1, this is m2, this is m3, m4. So these powers are all different. Alright? So you must be able to identify a power. And if we talk about power, don't tell me about ESCOM or electricity or battery power. Power in maths deals with bases and exponents, and the whole thing together is called a power. And if the indices are different, then the powers are different. Alright, so we're going to stop here. Now, the last time we were dealing with powers and we said we end there. Well, the story doesn't really end there. It's actually, the story starts there. Powers are linked to terms in a very, very special way. Now, let's consider a term like 2x squared. So you can see that this term is made up of two parts. It's made of a part where there's only a number. And this number is called numerical coefficient. And the other part, and this other part you can see, is actually a power. Or you can also call it a literal, because it comes from the word letter. Because it's got a letter in it, it's a literal coefficient. So you can see powers and terms are linked. We're looking at the term 2x squared, and this term is made up of two parts. The 2 is called a numerical coefficient, and the x squared, which is a power, is called a literal coefficient. Right. Now let's look at another example. Minus 3m cubed. Now we are looking at a term here. Now this term is made up of two parts. The numerical coefficient is minus 3. And it is also made up of a power, and the power is m cubed. Or we can say that the literal coefficient, it's supposed to be a little dash here, is m cubed. Alright, so we're going to make our life easy, and we're just going to talk like this. We're going to say there's a number here and there's a power there. So we're not going to worry about these big words. So we're going to make it very clear in our mind. We're always going to talk like this. We're going to say, look, here is a term 2x squared. It has a number and it has a power. Here is a term minus 3m cubed. It has a number and it has a power. Because we are moving on to a new section called like and unlike terms. So when we go to the section on like and unlike terms, we must be able to look and check and say what is the number, what is the power. What is the number, what is the power. Once we clear in our mind what is the number, what is the power, we will then be able to say whether something is like or whether something is unlike. So now to complete this little story, let's move on to the right hand side of the board. So if you take an example like this, if I show you m squared and 5m squared, I'm showing you two different terms. But the powers are exactly the same. Don't worry about the numbers. The number here is 1, the number there is 5. You don't have to worry about the numbers. You must concentrate on the powers. The powers are exactly the same. The powers are the same. Therefore, m squared and 5m squared are like terms. So this is how powers is linked to terms. Let's take another example, number 4. 3m and 5m squared. Do not worry about the numbers. You must always worry about the powers. Now look at the power. The power here is m to the 1. And the power here is m squared. So, the powers are not the same. Therefore, the terms are unlike. So, we say that terms are like terms if their powers are exactly the same. We say that terms are not like, or terms are unlike if their powers are different. Alright? So what we're going to do now is we're going to put in a little exercise, and then we're going to see which terms are like and which terms are unlike. Alright, now before we do an exercise on like and unlike terms, we need to get back to powers and clarify one more thing. We've got to make something clear. You see, if you take a power like m squared and m cubed, then these powers are not the same. They're not the same. Because the index is different. They're not the same because the exponents, now another word for exponents is indices. One index, many indices, because the exponents or the indices are not the same. Although the bases are the same, the indices are not the same. Therefore, these powers are not the same. Alright. Then, if we look at another example, these powers are also not the same. because the bases are different. So you see the first example, the bases are the same, but the indices are different. Therefore, the powers are not the same. In the second example, never mind the indices are the same, but the bases are different. Therefore, these powers are not the same. Right, so if we look at number 3, A and B, these are bases. The indices are exactly the same, but these powers are not the same, because the bases are different. So let's take another example. X cubed and x cubed. Well, these bases are the same, these powers are the same, therefore these powers are the same. So, for a power to be same, the bases must be the same. You can see the bases are x and x. And the indices must be the same. So, let's go from one side. The bases are the same, but the indices are different. Therefore, the powers are not the same. The indices are the same, but the bases are not the same. Therefore, the powers are not the same. The bases are different. Therefore, the powers are not the same. But in this example, the bases are exactly the same. The indices are exactly the same. Therefore, we can say that these two powers are exactly the same. Now, you would have to be able to identify powers which are the same for you to work out whether terms are like or unlike. So in our next session, we're going to go on to like and unlike terms. Right? We're going to take a small break here now. Alright, so to summarize, in our minds we should be very, very clear. In our minds we should be very, very clear that powers are the same if the bases and the indices are the same. For example, 5x squared and minus 7x squared are showing same powers. So, we must be able to identify same powers. 5x squared and minus 7x squared. The power here is x squared, the power here is x squared. The bases are exactly the same, the indices are exactly the same, therefore these two powers are the same. Now this is a very, very important statement, and you must be very, very clear about this in order to work out like and unlike terms. If you're not clear about this, you will have problems with like and unlike terms. So, it might be better then to just do one more example and say 6x and 6x squared are showing powers which are not the same. Because if you look here, you got x, but the index is 1. Here you got x, but the index is 2. For same powers, the base and the index must be the same. Here the bases are the same, but the index is different. So therefore these powers are not the same. So if you wish to complete the story properly, then we do one more. And if you take 6x squared and 6b squared, once again the powers are not the same, because this time the indices are equal but the bases are different. Therefore these powers are not the same, these powers are not the same, but x squared and x squared are same powers. Now this is a very powerful thing. You must be very clear about this in your mind, because once you've got this clear, you'll be able to differentiate between like and unlike terms. You'll be able to explain what is like and what is unlike terms. Alright, so we will take a short break at this stage and return the next time to find out what are like and unlike terms. Thank you. We are going to continue from where we stopped. Now what we did so far is we've been adding and subtracting terms. Now I know you want to know how to multiply and divide terms. Now if you wish to multiply and divide terms, you have to understand a little more about powers. So this morning we're going to concentrate a little bit on powers and then see how we use the knowledge of powers when we multiplying or dividing. Alright. So let's have a look at powers again. Now you will recall that we told you that here is 2 cubed. The whole thing is called a power. 2 is the base and 3 is the index or the exponent. Now, small English lesson. You talk about one index but many indices. Alright? One index but many indices. Alright, so there's a power. Now let's do a little experiment with powers. Suppose I told you here is 2 to the 5. So you need to know what this means. So what this really means is 2 multiplied by itself 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5 times. And if I work that answer out, 2 2s 4, 4 2s 8, 8 times 2 16, 16 times 2 32. Alright, so 2 to the 5 is really equal to 32. Okay, now let's take 2 cubed. So 2 cubed is equal to 2 times 2 times 2. And that gives you 2 times 2, 4, 4 times 2, 8. Now let's take 2 squared. 2 squared is equal to 2 times 2, and 2 times 2 gives you 4. So firstly, you must take a power and you must be able to expand a power and find its value. Take a power, expand it and find its value. Now, let's say I told you 2 cubed times 2 squared. So you will tell me, well, 2 cubed is 8.
and 2 squared is 4. So instead of 2 cubed, I'll write 8. Instead of 2 squared, I'll write 4. And 8 times 4 is 32. And when this happens, some bells start ringing in your brains because you realize, oh, I see something very exciting over here. 2 cubed times 2 to the 2 is giving you 32. And 2 to the 5 is also 32. So you realize that, look, 2 cubed times 2 squared is really 2 to the 5 by conducting this little experiment. And then when you look at this, you realize that, look, I can get that 5 by adding this 3 and that 2. So what this experiment is showing you is that it is showing you the first rule of powers when you multiply. So let me move on to that side and show you what is the first rule of powers when you multiply. Now remember, if you don't understand all this part right now, it doesn't matter. It's a demonstration of how we arrive at the rule. If you don't remember this, doesn't matter, but you must remember what I'm going to show you on the other side. Alright, so let's move on to the other side.
You're only going to